Alright, so we're going to be doing sum and difference identities for cosine. Now, there is a lot of blah, blah, blah before what you actually need in these notes. Okay, so they go through and actually talk about everything that you could even think of, but I'm going to get down to the basic of what we need for this. So, what we're going to do is we're going to find stuff that's not on our unit circle using what is on our unit circle. So, if you could please take out your unit circle. So you will use what is on your unit circle to find other things that are not on there. Okay, so let's take a look. My smallest unit of measurement is how many degrees? Not 0. What's the next one? What's the next one up from there? 30. That's going to be the smallest unit of measurement. So, I go 30, and the next one would be 45. Okay, and then so the smallest increment that I could actually use in between values here is the 30. That's the one that's actually going to get me here. So now I'm going to use addition and subtraction to be able to find other things. So I want to find everything in increments of 15. So these are things that are not on my unit circle. They do not come out to be a pretty little fraction, but they do come out to be a specific value. And that's what we're going to go through and find. We're going to find other values that are not on our unit circle. So, blah, 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 blah. Wah, 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 wah. Wah, 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 wah. Here you go, right here. You need this. So, we're going to start with cosine. So, we're going to find everything today in terms of cosine. Okay? So, all of it's going to be cosine. And I'm going to use these two things right here. So, I'm either going to be using addition or I'm going to be using subtraction. Make sense? Okay. Find the exact value of cosine 15. So I'm going to start this off with, so cosine of 15 degrees is equal to the cosine of something and something. 45 and 30. What am I going to do with the 45 and 30? Subtract, right? So it's going to be 45 minus 30, right? Okay. So 45 degrees minus 30 degrees. Okay. That's going to work. So in my terms, this is my A and this one's my B, right? So the formula for that, let's go. Let's see. It's going to be, let's back up. It's going to be a minus, so it's cosine A, cosine B, plus sine A, sine B. Okay.
Wait, what? I'm confused. Question. Where did you get the 45 and 30?
Those are two numbers that are on my unit circle, right?
Okay.
Those are known values. We're going to use known values to find unknown values on my unit circle.
I thought you did it because it equal to 90 with 15.
Okay, right here.
There's a minus.
We're trying to find 15. Is 15 on your unit circle? No, it's not. So using what is on my unit circle, I'm going to use what is on there to find other things.
So go back to the...
Okay, so I'm going to find new values, and it's not going to come up on my calculator because it doesn't work out right.
So you use the top formula and the bottom formula both like in one problem, right?
No. I choose which one I need. So we decided that we're using 45 minus 15, right?
Then why were you pointing at the bottom one with the plus sign?
What do we use? 45 minus 15, right?
45 minus 30.
Or, I'm sorry, 45 minus 30, right?
Yeah.
45 minus 30.
Oh. Okay, because I thought you were like, I don't know.
So my formula is right here. Yes, that guy.
So, what is equal, like, this, like the cosine A is right next to cosine B, does that mean it's multiplying? Or what?
Yes, it's multiplication.
But what are we?
And it's sine of,
Yeah, it's a multiplication. This is my formula. I haven't done anything with it yet. I'm just trying to pick out which one I need.
so we multiply both cosines.
I haven't got that far yet. I'm still just trying to tell people what we're doing.
Yeah.
Okay. So at this point, my A is 45, my B is 30, right? Okay, so I'm using this bottom one right here. So it's going to be cosine A, cosine B plus sine A, sine B. Now, in this case, my A is 45, right? So cosine 45 cosine 30 plus sine 45 sine 30.
Where are you getting sine?
From the formula.
Did you look at the formula?
Yeah, but I'm saying like I get where you got legit sine, but why are you plugging 45 and 30 into both sides?
Because
and
it's the same
cosine?
number.
Okay, so look at,
I'm asking.
that's an A, right? That's my A. That's the B. Let's go to the formula. Cosine A, cosine B, plus sine A, sine B. Okay, so we said A was 45, so it goes there and there.
Okay.
B is 30, there and there. Now, using that unit circle that you guys have in front of you right now, so cosine at 45 is what value?
Square root of 32.
Times cosine 30
Square root of 3 over 2.
plus sine 45
Square root of 2 over 2.
sine 30.
I don't remember.
And then, wait,
Are they supposed to like equal the same?
No,
Just leave it like that? So
almost. I'm waiting for people to actually write this down. So, what's happening in between these two things?
you have to multiply them.
They're multiplying, right? Okay. Same thing over here. These are multiplying. Order of operation. What comes first?
multiplication.
Multiplication before my addition are here, right? Okay, so let's go ahead and do that. So when I multiply fractions, I multiply it straight across. When I'm multiplying a radical, two radicals together, okay, I can multiply the inside. But if it's not a radical and a radical, I just set them next to each other. But in this case right here, I'm going to have rad 6 over 4 plus 1 times rad 2 is just going to give me rad 2 over 4.
And then you
Add them
add them
together?
together.
Now, common denominator. Do they have a common denominator?
Yes.
Okay, they do. So my answer is going to be rad 6 plus rad 2 over 4. This is my exact answer.
You can't add together.
No. They're different different numbers. The only time that you could add them together if they were the same radical, and I would treat that like a variable. If they had like x and x, I would have 2x. But if I had rad 2 and rad 2, that'd give me 2 rad 2. I would have 2 of those.
This already looks like 10 times easier than the last one.
Okay.
Wait, where did you get the 6? Okay.
What's 2 times 3?
From the top to the
Yeah. Rad 2 and rad 3.
You're just going about.
Yeah, you multiply fractions across.
Okay.
Are we okay?
So that would be. what is our answer? Like, I know that's
This.
No, like I know that, but what is it? Like,
Cosine 15.
Yes, this is cosine 15 equals this.
so kind of like if we had cosine 30.
Yeah, you would just pick it off the unit circle, right? But these are things that are not on the unit circle that are in between. Okay, now, serious question. Could I get 15 degrees by using something else?
Yeah.
Could I have done 60 minus 45? Should it give me the exact same answer? Yeah, it actually will.
So we can use any.
Yes, you could use any for these combinations, yes.
So what if you were looking for another like 1 or something?
Huh?
If you were looking for like a cosine of 1 or something?
Cosine of 1?
Yeah.
You're going to find so anything in increments of 15 is basically what we're going to find. So there would be 75 here, so it would be 75. So you know there's 15 degrees in between here and here, right? So we're going to find right here. So 15 is between here and here. So we would also find right here, so this is 105. So all these things in here are basically equal to 15. These are separated by 15, right? Separated by 15. No, yeah, we're not gonna have that. No, that by that we're gonna have like half angles and stuff like that. So there is other ways of doing this, but it's using like half angles and just like third angles. Yes. Are you on my next example? You're killing me, Smalls. Yes. Huh?
I think for 11 and 12.
Right here. Cosine is here, so your sine is y by. That's wrong. These terms are wrong.
All right. So let's take a look at my next part of this example. Now, 5 pi over 12. Easiest thing to do for these types of problems is convert to degrees first. What is 5 pi over 12 as a degree? What would I do to figure it out? So it'd be 5 pi over 12 times 180 over pi, right? Yeah, so I'm going to convert it to a degree first. Because I've been doing this long enough to know that when people try to think about this in terms of fractions and radians,
It doesn't work.
yeah, it doesn't work out very well. The math actually works out very simple, but for people to look at it and see what it's supposed to represent, I have trouble with it. So, what is this one going to come out to be? 75? So this is 75 degrees. Okay. So now I'm going to find the cosine of 75 degrees, which is going to be a cosine of, what is it?
How do they do that?
45 plus 30. Okay.
Are we basically only going to be using the,
Yeah,
what is the first?
A lot of stuff in the first. You're gonna have to find stuff in like the second and third quadrant, but it's the same thing. You're adding, subtracting numbers that you know to actually find one in between.
And so like I could use like, for example, I could do 150 plus 30.
Yeah.
And it's fine.
Yeah.
Okay. So there won't be an issue.
Yeah. Yeah.
Is it just always plus or like?
Wasn't our last one a minus?
So does it matter how?
No, it doesn't matter. It doesn't matter. So if I decide that I'm going to use a plus or a minus, okay, so on this case I used a plus. What could I use instead as a minus?
120 minus
45?
5, yeah.
120 minus 45 would get me the same spot.
So,
Yes.
so last time, at the beginning, it was a minus, and then you changed it to like plus.
Why?
Plus. So,
Because of the formula, right?
yeah. So if that one, so how we're doing plus now, it's going to be minus? Like it's always
It's on the
opposite?
formula.
Yeah.
Okay, only for cosine does that work.
Oh.
If you're trying to memorize it, that's cosine. Yes, so there was another question, Manny?
Well, like what she said earlier, if we only use 45 and 30, how do we know which ones do we use, next time? Like, say in the second quadrant.
Oh, any combination that you
Anything
want
that
for this
gets
to work.
So
75.
Any combination. Now, the math works out. It does. It works out every time. So sometimes your numbers will be backwards. So like on my previous problem, if you use something else, you might have had rad 2 plus rad 6 over 4. It's equivalent to the same answer. It's the same thing. Okay? So for this one right here, I have to go back to my formula. So it's going to be the cosine of 45 cosine of 30 minus sine 45 sine 30. Where did I get that from? Here it is. I used addition this time, didn't I? So the addition one is a plus b, and so it's going to be cosine a cosine b minus sine a sine b. Alright, so for this case right here, let's take a look. Cosine 45 is going to give me rad 2 over 2. Cosine 30 is rad 3 over 2 minus sine 45, rad 2 over 2, sine 30, 1/2. Multiply fractions straight across, so I'm going to have rad 6 over 4 minus rad 2 over 4. They already have a common denominator, so I can combine those up. So it's going to be rad 6 minus rad 2 over 4.
This seems pretty simple.
Better than the last.
Don't say that, because that's gonna get like
I already told you guys the last section is probably one of the hardest ones in this entire course. So,
And it about killed us all.
And it literally made me cry.
you know what? I
I would
I
never cry over
tried to warn you guys. I knew it was coming, and that's why I spent 2 days of just homework days and all the time that I spent in here trying to help you guys, walk you guys through it all. So I do understand. I really
You didn't even
do.
help your geometry kids that day.
Nah, I know.
You're like, go next door.
Okay.
What a
So
bad teacher.
find the exact value of this one. Now, what formula was used on this one?
The first one.
The first one. So it's going to be, this one is going to come up to be, since this is a minus sign,
It's gonna have to be cosine.
so it's the cosine of a plus b here, right? So that if that one's cosine a plus b, so now I'm working this backwards. I have it all worked out. I have all this. So now it's going to be the cosine of a, which is 87, plus 93. What is, I get 180, right? So let's see. So cosine of 180, is that on my unit circle?
Yes.
Yes, it is. It is on my unit circle, which gives me what?
-1.
But I thought it couldn't be.
And that's it?
I'm using things that are not on my unit circle here.
To find something that is.
Oh, so now we're finding something wrong.
And now you're doing it backwards.
That's it?
Yeah.
So
And
negative
that's
1 would be
it for the
the
notes
answer.
today?
Mm-hmm.
That was so easy.
Okay. All right.
I was so scared to come to class this morning, dude, not to lie. I was terrified.
All right. Don't forget, like and subscribe. Zoe's gonna do some tricks if you guys get 100 views.